Today, rapidly evolving digital world, cybersecurity threats are taking on new and unexpected form. One of the latest and most concerning trends is called AI squatting. Unlike traditional attacks that rely on exploiting software bugs or waiting for human error, AI squatting leverages the quirks of artificial intelligence itself. Hackers are now targeting the hallucination, those convincing but fictional outputs generated by large language models. This marks a significant shift. AI squatting is a new breed of cyber attack where hackers weaponize the hallucinations of AI models instead of targeting software vulnerabilities or human mistakes. When you ask an AI for a resource or a code library, it might generate a plausible sounding but entirely fake website or package name. Attackers are now predicting these hallucinations and registering the domain or creating the software packages before anyone else does. This means that when users trust and follow, AI generate. One major form of AI squatting is called phantom squatting, which specifically targets web domain. Here's how it works. Large language models often invent URL that sound legitimate when recommending resources like login portals or support center. Hackers take advantage by querying multiple AI models to find these recurring, non-existent URL. Once identified, they register these domains themselves. So when a user clicks on an AI recommended link, they're sent to. Consequences of phantom squatting are not just theoretical. For example, Palo Alto Network's unit by Alice uncovered a case where AI models repeatedly invented a marketplace domain for a national postal service. Hackers noticed this pattern, bought the domain, and set up a highly convincing phishing site. Unsuspecting users who trusted the AI recommendation ended up handing over credit card details and identity documents to criminals. This real-world case highlights just. The dangerous variant is halu squatting, which targets the software supply chain. AI coding assistants like GitHub Copilot or ChatGPT sometimes fabricate non-existent software packages or libraries when developers ask for installation instruction. Attackers monitor these hallucinated package names, create malicious versions, and upload them to public registry. If a developer blindly copies and pastes the AI command, they can unknowingly inject malware into their company. Why do large language models hallucinate these specific URL and package names? The answer lies in how these models are built. LLM are designed to predict the next most logical word or phrase based on patterns in their training data, not to verify real-world facts. When asked for a resource, they generate something that sounds plausible, even if it doesn't actually exist. This statistical, word prediction nature is a fundamental part of their architecture, or guardrail. Additional security measures are not enough to stop AI squatting. These attacks don't require malicious prompts, jailbreaks, or exploiting known software vulnerability. Instead, they exploit the very nature of how LLM generate text. Since hallucinations are baked into the architecture, there's no simple patch or update that can fix the problem. Even as AI models improve, the risk remains because the models are still predicting what seems most likely, not what's actually true. This may. Scale of AI squatting is already massive. According to Unit by Ali, over 13,000 malicious URL linked to hallucinated domains have been identified across 913 major brands. Even more alarming, nearly 250,000 hallucinated domains remain unregistered and open for exploitation. As more businesses and individuals rely on AI for recommendations and coding help, the potential for widespread damage grows. This is how can enterprises protect themselves from AI squatting? The key is to verify every AI-generated link and code package before using it. As enterprise tools move toward agentic AI, where systems autonomously browse, download, and execute, this verification becomes even more critical. Organizations should implement strict validation processes, educate employees about the risks, and monitor for suspicious domain registration and package uploads. By staying vigilant and